Hello and welcome back to Math 1324. We are still in Chapter 5, Linear Inequalities and Linear Programming. And today we're going to look at the second section, Systems of Linear Inequalities in Two Variables. So let's go talk about how to solve systems of linear inequalities graphically. Some definitions. To solve a system of linear inequalities in two variables graphically means to find the graph of all ordered pairs of real numbers, x, y, that simultaneously satisfy all the inequalities in the system. So we're going to graph all the inequalities of that system. And then you want to find the ordered pairs that satisfy all of those inequalities. The graph is called the solution region for the system. And the solution region is also called the feasible region. You're going to see that come up later on in the chapter. So to find the feasible region, graph each inequality in the system and take the intersection of all the graphs. A quick note for simplicity. We will only consider systems of linear inequalities where equality is included in each statement in the system, so that we have boundary lines that are solid and not dashed. Okay, the process to find the feasible region. Graph each inequality in the system and take the intersection of all the graphs. We've said that 2 or 3 times now, but let's actually go do an example. So find the feasible region of the system x plus y greater than 6 and 2x minus y greater than or equal to 0. Okay, for the first inequality, x plus y greater than 6. I'm going to solve the corresponding equation. So x plus y equals 6. And I'm going to get it in y equals mx plus b form. Y equals negative x plus 6. So 1, 2, 3, 4, 5, 6. And my slope is negative 1. My line is here. All right. Now I'm going to do a test point. I'm going to test 0, 0. Is 0 bigger than 6? Oh, sorry. Fix this. It should have an equal to underneath it. Greater than or equal to 6. Sorry about that. Is 0 greater than or equal to 6? That's false. So we want to shade this region. Okay, now for the second inequality of the system. I have 2x minus y greater than or equal to 0. So if I do 2x minus y equals 0, I get y equals 2x. The origin is the y-intercept. The slope is 2, so up 2 over 1. It 2 is going to be a solid line. All right, if I can't pick 0, 0 this time, but let's pick, say, 3, 0. If I plug in 3 for x, I get 6. 0 for y is 0. Is that greater than or equal to 0? Is 6 greater than or equal to 0? Yes, it's a true statement. So I want to shade this point 3, 0. So I'm shading this region. All right, now my answer is where these two regions intersect. So I'm going to do it in green. I've got this boundary line, and all of this region. That is my answer to the system of linear inequalities. That green is the answer that I'm looking for. Let's go do this again. Find the feasible region. 3x plus y less than or equal to 21. Okay, I'm going to do 3x plus y less than or equal to 21. So if I were to graph 3x plus y equals 21, I would have y equals negative 3x plus 21. Okay, I'm going to have to make each of these probably worth 2. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. And 21 is right in the middle. If I go down 3, let's just do it this way. X, Y. If Y is 0, X would be 7. And if X is 0, Y would be 21. So if I do 2, 4, 6, 8, 10, I'm going to have 7, 2, 4, 6, 7. Here's my line. Oops. Now let's go do a test point. If I do 0, 0, is 0 less than 20 or equal to 21? Yes. So I want to shade this part. All right, that's the first inequality. Now for the second inequality, I have x minus 2y less than or equal to 0. So if x minus 2y equals 0, negative 2y equals negative x, so y equals 1/2 x. 0, 0 is the y-intercept. Up 1 over 2. So here's that line. Now if I pick a test point, let's pick 10, 0. Oh, you know what? No, that still works. Okay, if I pick a test point of 10, 0, I would have 10 minus 0 less than or equal to 0. That's false. So I want to shade this part. So my answer is where it's green. My answer would be this boundary line here, this boundary line, oops, this boundary line, and all of this green shaded. That's my answer. That's the feasible region for that system. Okay, let's do this again. Find the feasible region. Okay, we now have 3, but this one, x greater than or equal to 0. Here's the line x equals 0, and I want everything bigger than or equal to 0. So there's the line x equals 0. If I want bigger than or equal to, I want this region. Okay? Now I want y bigger than or equal to 0. Here's y equals 0. That's the x-axis. And I want everything bigger than. So look at what those two things do. When I say x bigger than or equal to 0, y bigger than or equal to 0, that restricts me to quadrant 1 only. Okay? All that does is restrict you to quadrant 1. Now let's go look at the first inequality here. 2x plus 3y less than or equal to 12. I'm going to graph that by using the intercepts. If x is 0, y would be 4. If y is 0, x would be 6. How am I getting that so fast? If x is 0, I have 3y equals 12, so y would be 4. If y is 0, I would have 2x equals 12, so x would be 6. So I have the point 0, 4 here, and 6, 0 right there. Okay, now here's my line. I've got to pick a test point, 0, 0. If I plug 0 in for x and y, I get 0 less than or equal to 12. That is a true statement. I want to shade the half plane that contains 0, 0, but I need to stay inside quadrant 1. So I'm only going to shade this part. That's the answer to that system. Only that little piece that's dark green. It includes the axes. It includes this boundary line. That is the only part that I want right in there. And let's go talk about a couple more definitions. A corner point of a feasible region is a point in the solution region that is the intersection of two boundary points. So let's go back up here to this previous example. Remember that the green was the feasible region. This point would be a corner point. What is that? 0, 4. This would be a corner point, 0, 0. And this would be a corner point, 6, 0. That dark green is the feasible region, and those red dots are corner points. Now, notice that we can draw a circle around that feasible region. Back down here, a feasible region of a system of linear inequalities is bounded if it can be enclosed with a circle. So that previous example was a bounded feasible region. If it can't be enclosed with a circle, it's unbounded. So let's go look at an example. Find the feasible region and list the corner points. All right, I'm going to remind you that those two inequalities, x greater than or equal to 0, y greater than or equal to 0, all that does is restrict us to quadrant 1. So I just drew quadrant 1 here on my graph. Now let's go talk about these other two inequalities. 2x plus y less than or equal to 22. If I graph by intercepts and I let y be 0, I get 2x equals 22, so x is 11. If y is 0, if x is 0, I get y equals 22. All right, so here we go. X has to be 11, y has to be 22. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to let each one be 2. This is 20. This would be 40. 1, 2, 3. There's 10. There's 20. There's 10. Okay, so for my blue, I have 11, 0. So right here. And I have 0, 22. All right, test point. Do I want to shade up here, or do I want to shade do I want to shade up here, or do I want to shade down here? That's the question. So let's go pick a test point. 0, 0 will work. So if I pick 0, 0, I get 0 less than or equal to 22, which is true. So I do want to shade down here. All right, that's the first inequality. And let's go to the second one. 2x plus 5y less than or equal to 50. 2x plus 5y less than or equal to 50. If I graph by intercepts, if y is 0, I get 2x equals 50. So x is 25. If x is 0, I get 5y equals 50. So y is 10. So I have the point 0, 10, and I have the point 25, 0, which would be here. So there's that line. All right, what about this point? 0, 0. Is 0 less than or equal to 50? The answer is yes, so that's true. So I want to shade down here. So my feasible region is the region in green. Now it wants me to list my corner points. Where do these lines intersect? Okay, the corner points of my feasible region, I have the point 0, 10. I have the point 0, 0. I have the point 11, 0. And I have this point. Now, graphically, I can't tell really right now, but to find this point, I need to solve where does the red line equal the blue line? So that's solving a system of equations, right? So that's asking where does 2x plus y equal 22 and 2x plus 5y equal 50. Now to solve that, I'm going to multiply the first equation by -1, so I get negative, negative, I'm going to scoot that over a little bit, negative. I eliminated the x's, so now I have 4y equals 28, so y is 7. If y is 7, 2x plus 7 equals 22, so 2x would equal 15. So x would be 7.5. So my corner point here is 7.5, comma 7. So that's my last corner point, 7.5, comma 7. Now, to summarize what we just did, these two, hold on. Okay, these two inequalities restricted us into the first quadrant. When I did these two inequalities, I found my feasible region in the first quadrant, and it was the one that's here in green. Then I found my corner points 0, 10, 0, 0, and 11, 0 were easy to find. I had to go find this corner point by solving when I put those two equations into a system and solving where they intersect. Last question. Is this feasible region bounded or unbounded? Since I can draw a circle around it, it is bounded. Last example, find the feasible region and list the corner points. X greater than or equal to 0, Y greater than or equal to 0. That restricts us to the quadrant 1. Now let's go graph 5x plus y greater than or equal to 20. 5x plus y greater than or equal to 20. If y is 0, then 5x equals 20, so x is 4. If x is 0, y would be 20. So to graph that, 0, 20. Here's 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 15. 1, 2, 3, 4, 20. All right, there's the first point, 0, 20. And then I want 4, 0. 2, 3, 4, 5. So 4, 0 is here. Stop it. Okay. So that slope is actually negative 5, right? So I'm going to go down 5, right 1. Right 1, down 5, right 1. Okay, there's my line. Now, do I want to shade to the left of that line or to the right of that line? So I'm going to do a test point. Is 0 bigger than or equal to 20? No, so that's false. So I want to shade from here this way. All right. Now let's go do the second inequality. And that inequality says x plus 3y bigger than or equal to 18. X plus 3y bigger than or equal to 18. Graphing intercepts. If y is 0, x would be 18. If x is 0, 3y would equal 18, so y would be 6. So I have the point 0, 6, and I have the point 18, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 18, 0 would be here. So down 1, right 3. Down 1, right 3. Okay, so here's that line. Now if I do a test point 0, 0, zero bigger than or equal to 18 is false. For this one, I want to shade this way. Now I have a little bit of problem seeing where that one line is. Give me just a second. There's the blue, and that's making the red line go up. And then this one was here, and it went this way. All right, so my feasible region is that green. Oh boy. Okay, what are the corner points? This is a corner point here at 0, 20. So 0, 20 is a corner point. This is a corner point. What is that one? This graph is a little easier to read. 1, 2, 3, comma, 3, 5 is a corner point. And 18, 0 is a corner point. And that's it for corner points. Now, can I draw a circle around this? And I'm going to pretend like I can. And then I'm going to tell you, don't forget that this goes on forever this way, right? And this way. And then the blue also goes on forever this way and this way. So am I able to draw a circle around that feasible region and keep the feasible region inside that circle? The answer is no. So this is an unbounded feasible region. All right, let's look at example number 3. Which regions below are bounded? Okay, bounded would be region 2, region 3, and region 4. So 2, 3, and 4 are bounded. However, region 1 is unbounded because it keeps going forever in those directions. All right, let's go look at an application and see how systems of linear inequalities in two variables can be useful. A patient on a brown rice and skim milk diet is required to have at least 800 calories and at least 32 grams of protein per day. Each serving of brown rice contains 200 calories and 5 grams of protein. Each serving of skim milk contains 80 calories and 8 grams of protein. How many servings of each food should be eaten per day to meet the minimum daily requirements? Okay, we're going to let X be the number of daily servings of brown rice and Y be the number of daily servings of skim milk. Do you see how we get the two inequalities, X greater than or equal to 0, Y greater than or equal to 0? The reason is you cannot eat a negative number of daily servings. Okay, now let's go after our calories. Okay, we need to have at least 800 calories. Brown rice contains 200 calories per serving, and skim milk contains 80 calories per serving. All right, so we get 200 calories per brown rice serving plus 80 calories per serving times that many servings of skim milk. And I want that to be at least, so greater than or equal to 800. Let's go graph that one. So 200x plus 80y has to be greater than or equal to, was it 800? Yes. Okay, if I graph intercepts, I want that to be x. x and y. If y is 0, I get 200x equals 800, so x is 4. If x is 0, I get 80y equals 800, so y is 10. So let's go graph 4, 0, and 0, 10. Here's 5, 6, 7, 8, 9. Here's 10. Here's 5. Here's 10. All right, so I have the point 4, 0, and I have the point 0, 10. Now, what's the slope of that line? Slope would be negative 200 over 80, 20 over 8, 5 over 2. There we go. There's another point. So here's that line. Now, test point, 0, 0. Is 0 bigger than or equal to 800? No, so that's false. I do not want to shade 0, 0. So I am shading this part. All right. There's that one. Now let's go do the grams of protein. So I need at least 32 grams of protein. Brown rice has 5 grams of protein per serving, and skim milk has 8 grams of protein per serving. So my last inequality would be 5x plus 8y has to be greater than or equal to 32. So this is my system of linear inequalities. 5x plus 8y greater than or equal to 32. Okay, graphing the intercepts. If y is 0, 5x is equal to 32. So x equals, what is that going to be? 6 2/5, so 6.4. If y is 0, sorry, if x is 0, I get 8y equals 32, so y equals 4. So I have the point 0, 4, and I have the point 6.40. Now, a test point is 0, 0, so I get 0 greater than or equal to 32. That's false. I do not want to shade 0, 0. So on the red line, I want to shade this way. So the red line, I'm shading here. All right, there's my feasible region. It's huge. Okay, that is an unbounded feasible region because it keeps going this direction and this direction. My corner points are going to be here, so corner point is going to be 0, 10. It's going to be this point, which I'm thinking is 3, 2. I'm going to go check that in just a second. And it's going to be this 6.40. All right, I need to check this point here. I would do that by solving the system 200x plus 80y equals 800, and 5x plus 8y is equal to 32. Okay, let's remember what we did last chapter and do the augmented matrix. Remember doing that? And then I want to RREF it. All right, let me get the calculator pulled up. Okay, second matrix, edit. I'm going to do a 2 by 3. I have 200, 80, 800. Then I have 5, 8, 32. Okay, I'm going to do second matrix math all the way down to RREF. And then second matrix A. 3.22. All right, so the answer to this problem, this was not 3.2, this was 3.22. The answer to this problem, how many servings of each food? So the number of brown rice servings should be 3.2. And the number of, at least 3.2. Number of daily servings of skim milk, hold on. That corner point was 3.2, 2. So as long as you are in this feasible region, whether you be at a corner point or not, you have satisfied that dietary requirement. You would be getting at least 800 calories and at least 32 grams of protein. No matter what point you picked in here in this feasible region, you would be getting those requirements. That's it. Go do the homework associated with this section, and we'll see you next time.